Okay, well, I think we can get started. I think more people will be joining us, but for those who are here at 7, we shouldn't delay. So welcome to our this week's class in the LaRouche-Pak class series. My name is Bruce Director. We're joined tonight by Ian Overton, who made the first class last week. And for those of you who weren't here for the first class, you can get a recording of it posted up on the LaRouche-Pak website. As I mentioned last week in my introduction, that Ian is a graduate of the LaRouche Youth Movement and has studied with LaRouche personally, as well as throughout on his own, the principles of LaRouche's economics and the follow-up of the LaRouche Riemann model and LaRouche's idea of history. He also was the principal author of the document we submitted, LaRouche-Pak submitted to the 1776 commission that President Trump had established as a counter to the 1619 project. So he's quite knowledgeable about the matters he's going to speak about. And I just want to, before as introducing the subject matter, just briefly run down. It's obviously been a very eventful week. One of the main events, of course, was the not guilty verdict in the Kyle Rittenhouse case, which is a very good victory for the United States continuing to be a republic, despite all the efforts to try and destroy that. I would point people to a post on the LaRouche-Pak website by Barbara Boyd, which discusses that question quite importantly. And there's, but the week, that was the end of the week. The beginning of the week, of course, started with, galloping inflation, continuing, complete denial on the part of the, whatever you call this administration. It's not really the Biden administration, it's some collective, which Biden, they sort of trot out there. And as Biden himself says, he's always been told what to say. So whoever they are, who's telling Biden what to say, we know some of their names, but who knows, who's telling them what they say. This is the first US presidency that's run by, like the Wizard of Oz, by some guy or collection of people behind the curtain. Anyway, complete denial. He had his conference with Xi Jinping, and there's not much we can say about that because most of the everything that both the United States and the Chinese government have said about it is obviously just political smokescreens. But what's clear is that Biden, and of course, everything that comes out of the Biden administration is complete lies, so you can't pay any attention to any of that. But what we do know is that the plan of this collective is to try and reverse what President Trump did in removing the United States from the globalized agenda and to what we here at LaRouche-Pak call re-Americanize the economy and build up America as an industrial power. We know that Biden's intention is to reverse all that, to reintegrate the United States into some globalist arrangement dictated by the Anglo Wall Street financial interests. And that's what's governing all the policy, including this crazy, what they claim is Build Back Better, but it's probably better said, dismantle the economy now, which is exactly what it proposes to do. I point you again to a new article on the LaRouche-Pak website by Mike Carr, which deals with the third point of our Re-Americanize the Economy resolution, which points out where the United States actually should be going instead of down this road of destruction and climate change and so forth. So the week has been quite eventful in that regard. It's going to continue to unfold over the next week. And it's very easy to get sort of bounced around with all these developments, trying to figure out what's actually going on, giving my Wizard of Oz analogy, behind the curtain. And Ian has been presented last week some very important ideas about how to basically understand what's going on, because the American people don't want whatever Biden's administration is trying to do to the economy, this reintegration into globalism. They don't want that to happen. We're not going to let it happen. President Trump has made it clear he doesn't want it to happen. The American people rejected it and are continuing to reject it. The more they get a taste of it, the more they know that's why they elected Trump in the first place, to get us out of what was the mess we had, this globalist mess we had been induced into over the previous 40 years. And we're not going back to that. So, but the issue here is that Ian's going to present to us tonight is, what are the tools, what is the way of thinking, and that is necessary to be able to both understand what's happening to us, and more importantly, what we actually do about it. It's easy to get mad about everything that's going on, but you got to go beyond getting mad. The success of the United States over our history, from our revolution through the Civil War, through the Depression to the current time, is people, the American population got beyond just being mad and actually reclaimed the direction of their republic for themselves. And that requires key ideas, key ways of thinking that LaRouche explored and developed in great detail. And these are the things that we hope to be able to make available to everybody on this call and to people beyond. So Ian is going to present this to us, present some thoughts for us tonight. And we're grateful to have him, and we'd like him to begin now.
All right, great. Well, thank you so much for that introduction, Bruce. Yes, this is the second part of my series on what I called Escape from Astro World. And for those of us who are quite obviously in Houston and experienced the Astro World tragedy, that is something that was really relevant in the news just the other week, when a number of people were basically smushed to death at a concert. And I want to remind people briefly what I talked about last week, because I think this class here that the things we're going to go through today is going to it's going to build off of what I talked about before. So what I went through briefly, very briefly, last week, is that I was using the news of what happened at Astro World as a convenient way to introduce a deeper metaphor, which is that when we talk about re-Americanizing the economy, when we talk about going back to a policy orientation in this country typified by great projects, by exceptionalism, and a caring attitude for our citizens to foster, nurture, and develop within them a creative spark that empowers us to rise above our circumstances and make really great things happen. That what we often find when we're out there organizing in the population is that you will run into people who say, well, that's wonderful, but we can't win. We can't do it because of some various thing, which is very horrifying and bad, and is much more powerful than you or I as individuals. And therefore, because of that, we're unable to succeed. And so there's a cynicism and a pessimism, which is really baked into the dominant cultural paradigm that we are fighting against. And I had dubbed that haunted house syndrome, as similar to people who are feeling stuck in a haunted house and can't get out, and they know they're in a haunted house and they hate it, but they don't know what to do. They don't know how to escape from that. And there's a deeper way of even considering that metaphor, which goes back to Plato's allegory of the cave. in his Republic. And the allegory of the cave is a allegory. It's a metaphor. If you imagine a group of people who are all chained up inside of a cave, so they can't look to their left and right, and they're staring at a wall, and behind them is a fire, and between the fire and the people who are chained are other people who are parading around various cutouts and things to cast shadows on the wall. And the chained up people are looking at those shadows and think that's reality because they don't know any better. And maybe you have someone who manages to realize that they've been chained up and is able to break free of that or be brought out of that cave to then be introduced to the sunlight of actual true things and see how their the appearances on the cave wall were being constructed for them. You would help people get out of the cultural chains of slavery that have kept us in a servile state. And I discussed last week some of those things and how we can look at something from the standpoint of culture, and how that is actually being introduced to us to induce the kinds of backward types of cultural behaviors and norms, to where, I mean, one of the people who unfortunately died in the Astroworld tragedy was a 9-year-old. His father had taken him to the concert. This is a concert where they're not, I mean, the content of the music is not even trying to pretend anymore that you have the subject matter is, you know, having sex on drugs and partying and flashing all your money. I mean, this is the level of degeneracy which has become popular, and that's where some fathers and sons at least are considering taking their young children to have bonding moments with. Okay, and we discussed how when we look at ideas and the interplay and playing with ideas, especially ideas that are not even based upon something that's directly observable, but ideas in the mind, we can come to develop a method by which we have much higher insights into our own humanity, into our own creative process. And so I discussed some of that. And now I want to take the same subject. I want to rephrase the concepts that we're talking about, not more so from the standpoint of art and culture, but more so from the standpoint of science. And I think as we talk about science, we're going to discover that different people have very different ideas about what that means, and what is scientific thinking and what is maybe scientism as a logical religion. And so when we talk about the ideas and the policies that we think are needed to save our country from an actual dictatorship and from elements within our own government and elements within our own institutions, we need to be able to help people free themselves from being trapped in a nightmare. And so what I'm going to go through tonight is I'm going to go through some concepts. I want to caution people that what I'm going to be getting into is going to be, there's some density into the ideas, but I don't want you to get caught up so much in my examples, because each one of the examples that I'm going to be going through today the point is not the example itself. The point is actually a greater point. What we hope to get to here tonight, what I hope to get to here with you, and some of this may come out in the conversation period, is that there is a difference between rules for society, which are arbitrary, and rules for society, which are based upon a kind of natural law. And how to come to understand that, and how to develop concepts and principles to organize our society, which are fostering and nurturing the most important resource we have, which is not oil or Bitcoin or beautiful artwork or whatever things. The actual most important resource we have is the spark of creative genius in an individual person's soul. And that this spark, this power, this faculty of ability to have a scientific thought, to know something to be true, definitively, universally, is the engine by which future progress is powered. And that's a really important thing. Now, when we talk about something like Rittenhouse and the Rittenhouse case, this is actually a very useful way to approach the subject. Because what was at stake in the trial for Rittenhouse, this is as far as my opinion goes on the matter, is it wasn't really about whether or not the young man was guilty or not. And I also don't think it's really about whether it had anything to do with racism or not, or the rioting or not. I think what's really at the core of this is whether one worldview, which some people could typify as the cancel culture worldview, would prevail over another worldview, which was based on our justice system, the justice system established in the United States. And to be able to cause people to submit, to overturn the actual justice system in favor of that worldview. And so I think ultimately a lot of people do understand this, or they just may not have put it in such words. But what I'm going to do in looking at a question of, well, what is scientific thinking and how do we approach this? I think we'll find some very interesting and hopefully provocative for the conversation period, things to talk about. So what I'm going to do now is I'm going to share a screen with you, and I'm going to share a quote with you from a very evil person. And I'm going to do that because I think it's very relevant here for our conversation. Okay, so Bertrand Russell. Bertrand Russell was an aristocrat around the turn of the century, last century, 18 to 1900s, in England. He was very much in favor of preemptive nuclear war, and he was a mathematician, a philosopher who advocated policies to help promote empire, the British Empire. And he did this in collaboration with a lot of other people internationally. And he wrote a book in 1951. He wrote other books too, but I'm going to talk about this one first, called The Impact of Science on Society. And in this book, he makes a number of arguments in favor of, while pretending to warn against, the use of what he calls science to create a dictatorship. And I'm going to read some quotes from you. And in the background of the slide, I have a picture of Travis Scott, not from Astroworld. This is from an earlier concert. Very relevant picture, I believe, because it really captures what we're talking about here, where he has a shirt that says, "Put on a happy face," and a picture of a screwed planet, like the Earth with a screw through it, literally. And he's rapping about his subjects that he raps about. Anyway, so from this book, Bertrand Russell, he has a quote. He's talking about mass psychology. He says, "The subject of mass psychology will make great strides when it is taken up by scientists under a scientific dictatorship. The social psychologists of the future will have a number of classes of school children on whom they will try different methods of producing an unshakable conviction that snow is black. Various results will soon be arrived at. First, that the influence of home is obstructive. Second, that not much can be done unless indoctrination begins before the age of 10. Third, that verses set to music and repeatedly intoned are very effective. And fourth, that the opinion that snow is white must be held to show a morbid taste for eccentricity." And when you look at this, I want everyone to think about some of the conversations that we've been having in this country in the last year or two about, let's say, the 1619 Project, critical race theory, the president of the United States saying that white supremacy is the new Al-Qaeda, and that this is the most dangerous thing that we're facing as a country. What we're seeing is Bertrand Russell's results or recommendations or observations relating to how a dictatorship could be maintained without using troops, so-called, right, is happening very clearly in our schools and other institutions. There, when the failed candidacy of Terry McAuliffe in Virginia, when he was saying, well, you know, parents shouldn't have a say in their children's education, well, that's exactly what Russell had discussed and what he was talking about. The racists and other people you see on MSNBC, like Joy Reid and these people, the way they talk about, and also you see in the reactions to Rittenhouse being shown as not guilty on all counts. I mean, their morbid taste is, well, I just can't understand it. I don't understand how is this possible? It's obviously white supremacy. It's all these things. So the way they're talking about this stuff, it is right on the money in terms of what they're following Russell's formulas for these things. And he has another quote. He says, although this science will be diligently studied, it will be rigidly confined to the governing class. The populace will not be allowed to know how its convictions were generated. And when the technique has been perfected, every government that has been in charge of education for a generation will be able to control its subjects securely without the need of armies or policemen. Right? So this is very clear. This should be very clear to people who've been paying attention to what's been going on for the last few years, that this is what we're dealing with. We're dealing with mass psychology, trying to create a dictatorship without the need of armies or policemen, using a subversion of our institutions of government and school and other types in religion and other types of institutions, our entertainment, to create a situation and where that sort of power structure can be maintained. And so this is a very important, I'm going to make my first important point here. Albert Einstein, everyone would understand as a truly great scientist. In the first chapter, the opening point he's making in his book on relativity is he's making a point where he says a lot of people may remember Euclid from basic math schools, maybe not respecting him, or maybe not admiring him, but certainly being respectful of the fact of his incredibly difficult to learn set of axioms, theorems, postulates. And one of the things that we have to deal with is a question of truth, right? Is snow black or is snow white? Are all people who look like me white supremacist racists or not? I mean, the question of truth, as Einstein talks about it in his book, is something true because the answer is consistent with the starting premise? In other words, is it true because it's consistent? Or is it true because it's proven to be true? And the word proof is the same thing. Is the proof something that's illogically consistent from the starting premise, or is it something that you can actually demonstrate physically in the actual universe? So what I would like to do is I would like to go through a series of examples one at a time, where we're going to start to examine the difference between the first definition of truth as a logical system that is internally consistent, and whether something like that can ever actually exist in a complete way. And we're going to also counterpose that to a definition of truth, which is that which is physically provable in the world, in the physical universe. And we're going to examine the differences in laws based upon those two approaches, both of which call themselves science. The The spoiler alert, the first one's not actually sides. Okay, so we're gonna start. It's often helpful when we're starting to talk about proving things to resort to examples in math and geometry, because with math and geometry, you can actually be precise. Now, I was not a math guy. As I mentioned in my first class last week, I was majoring in college really in the social sciences, in what was not yet known as social justice warring and critical theory. Okay, so that's the background that I have. So for me, coming to do this has been a real renaissance period for myself over the last 10 or 12 years. So we're going to do an example here called doubling the square. So when you have a square, you have something with an equal length of and width, and you're multiplying the length by the width to get an area. It doesn't really matter what that starting length is. We'll just call it the number 1, as long as it's the same as the width. So 1 times 1 equals 1. You know, a length times a width equals the area. To get the length where the area is 2 requires having sides which are a very special number called the square root of 2. The square root is a number that cannot be measured with a ruler. If you try to express it in terms of decimals or as an integer, it repeats itself infinitely. And that repeating number is 1.41, repeating. So how do you actually generate a square if all you're starting with is the original square of 1? Well, as you can see in the upper right here on my screen, what I've done is I've taken the hypotenuse of the square, I've taken the diagonal, and made that the new line. And when you use that as a line, or as a side, a length and a width, that is actually the square root. That's where the symbol for a square root comes from, is from tracing the angle there between the bottom of the square, the hypotenuse, and the side of the new square that's been constructed. And the point of this, again, I don't want you to get hung up on doubling squares and lines and square roots and numbers and things like that. The point is that if we start with a formula, a math formula, well, to find a square with area of 2 is just square root of 2 times the square root of 2 equals 2. Well, how do you get that? It is actually a geometrical proof to find that number. And that's the point I want to leave you with on this example, is that when we are trying to come up with a mathematical expression, we need to be able to tie that mathematical expression to some kind of something for it to actually make sense. Here in this case, we've done it with geometry. And now I'm going to take it one step further. So Euclid had a series of postulates which were the basis of his geometric examples. And I'm going to talk about these 5 postulates. So the first one is a straight line can be drawn by taking any 2 points. Just pick 2 points. You draw a straight line between them. He calls that a line segment. From that, you can extend infinitely. If you take one line segment and you rotate it around itself, he calls that a circle. When you have 2 line segments that intersect at right angles, all 4 of those right angles will be 90 degrees. They'll all be equal in their angle. And the 5th one, if you have 2 lines that intersect a third in such a way that the inner angles are not right angles, or at least one of them is less than a right angle, then those 2 lines must inevitably at some point cross each other. And the inverse of that is that if you have a line and you have 2 lines that intersect it and both of them are at right angles although all those lines are at right angles to each other, then those two lines will never intersect. They will be parallel, and they can be extended infinitely and will never intersect. And that's called the parallel postulate. That's one of Euclid's more famous ones. And the reason that it's so famous is because it was actually refuted. And here's the refutation. If you look at the planet Earth at the equator, there you have the equator line, and then you have lines of longitude that are completely at right angles to it. And what happens when those right angles are descended all the way to the pole, the South Pole in this case? They meet. And what is being demonstrated here is that Euclid's geometry, from which many math formulas are generated, Euclid's geometry works if the underlying assumption is that the universe or the space that you're building your geometry around is a flat piece of paper. It works very well if you're just drawing a flat map, for example, or measuring the area of a table that you're producing in your workshop, something like that. But then when you actually try to use the geometry for purposes of cartography, map making, or traveling, or doing things that involve actually moving on a spherical surface like the Earth, you find that actually Euclid's geometry is not sufficient for that. Or this is especially true when you start to deal with things that are much, much larger or much, much smaller than the limitations of your vision. Okay, when we start dealing with the micro universe at the atomic level or molecular level, or we start dealing with extra large things such as navigating transoceanically, or dealing with rocket science and things like that, sending a satellite so that in 10 years it precisely passes Pluto to take photographs of it for the first time in high definition, right? That kind of stuff. You need a different geometry for that. You need a geometry which is actually based upon the physical universe in which you're operating, not a geometry which is based on unseen assumptions that actually the universe is flat, as in Euclid's case. And so this is a very important point. We want to understand here, we're not trying to memorize all of Euclid's postulates. What we're actually trying to understand here is that when we talk about generating a geometry from which we're writing formulas as annotations to describe something and prove something to be true, that geometry has to be physically constructed. We have to have a physical geometry, not an arbitrary geometry. And Bernhard Riemann made this point exceptionally clear in the late 19th century when he says that this is something that has to be, that geometry and math has to become a branch of science, not the math department. So I'm going to return to Bertrand Russell, and I'm going to take these examples, and I'm going to go one step a little bit more complicated. Sorry about that, but it's really important. So prior to writing his book where he was calling for a scientific dictatorship, he wrote another book called the Principia Mathematica with this guy, Whitehead, in 1910. And Russell was involved in a network of people who were meeting and discussing philosophy that was called the Vienna School. And these are people who were promoting a worldview called positivism. And as you recall from last week's discussion, the Frankfurt School and Theodor Adorno and the people who were pushing a critical theory, what became critical race theory, were in reaction against the Vienna School, and they were in reaction against positivism. In the doctrine of positivism, we have a lot of people who probably are not as well known to an American audience. Maybe one of them would be Ludwig Wittgenstein, and of course, Bertrand Russell. In the attitudes of empiricism, what these folks believed and pushed became the basis for the behavioral psychology school. And it also became the basis for what became known as cybernetics, the development of what developed off cybernetics into advanced computers, what we call machine learning or artificial intelligence, and a virtual reality. Here are the basic goals and tenets of what logical empiricism and positivism try to get you to go with. These are some of their underlying axioms from which they build their structure. The first is that only empirical or sensed objects exist, that metaphysical philosophies like conversations about the nature of man, God, things like that, virtues, these are actually, they're not just metaphysical or opinions, they're actually irrelevant. They're actually relevant to the conversation. And they should be not talked about. They should be ignored or written off as childish, youthful contrivances. And thirdly, that the universe of empirical objects and their relations can be measured and forecast using logical systems. And the Principia Mathematica was a book which I would call the precursor to a computer program, in which Russell and Whitehead were trying to take the body of human knowledge and be able to describe and define all knowledge and all future knowledge according to this logical structure. So what I'm going to do now is I'm going to give you a very brief example of how they do that, so that we can examine, not, again, don't get all caught up in all the details I'm going through. The point here is to present to you the, like I did with Euclid's postulates, the basic structure of his work, so that then, as I refuted the fifth postulate of Euclid by showing the underlying assumption, I'm then going to talk about the underlying assumption of Russell's structure. But I want you to consider that Euclid wrote a giant complicated book first. Russell wrote a giant complicated book much later. The overall goals of these same books are to convince people that that's what's actually going on here, is that kind of structure. So here it is. Here is all of it in one slide. Now I'm going to go back and I'm going to talk about it one at a time to avoid overload. So Russell, what he does is he says we're able to reduce all of human knowledge to axioms, sets, cardinal numbers, ordinal numbers, and real numbers. And from that, we're able to generate logical formulas from which we can anticipate all future knowledge. Okay, so an axiom is a hypothesis or idea which is so specific that it does not include additional assumptions. It's something which is boiled down to its essence that you can then test. For example, a musical phrase, or a hypothesis that all planetary orbits are circular, or a hypothesis that the foundational concept of the United States is the 1776 approach versus or the 1619 approach, right? Specific testable hypotheses. A set is a group of ideas that include some kind of common characteristic. So in my example here on the right, I have a group that I've called eighth notes. These are musical notes which have 1/8 of a beat. And I've grouped them together under that name, eighth notes. Cardinal numbers are numbers that count the number of things in a set. So here we have 6 eighth notes. Ordinal numbers are numbers that count the order of things in a set. So we have the first eighth note, the second eighth note, the third eighth note, and so forth. And then real numbers are numbers that are tangible objects without complex connections, like the square root of -1 and so forth. I'm not going to get into that. That's a whole other conversation. But if we set the bottom staff line in our musical scale as 0, then the first note is a -1 value. The second note, because it has a sharp next to it, is a 2.5 value, 3, 4, 5, and 7. So we're able to assign values to those tangible objects. We're able to place them in a certain order. We're able to count the number of those things. We're able to give those counted numbers of things that have been ordered and valued a name. And then we have the assumptions that are built in about those. Now, remember, what I was just talking about was empirical positivism. What we've eliminated from this conversation about music is we've eliminated all metaphysical discussion, and we're now talking about music from a literal standpoint of notes, their measure, their order, their relationships. It's all a logical structure, right? Here's the problem. Here's the problem with that. In this regard, there's really no difference between something like Mozart's Laudate Pueri that I played on last week's class and Travis Scott's Sicko Mode. Logically, what we're talking about is we're talking about all these eighth notes here. So in being able to create an entire system like this, here's how it was actually refuted. So Kurt Gödel, who was a collaborator of Einstein at Princeton, he was able to use logic and mathematical formulas. So he was speaking on the same wavelength with the same level of proof that it was being demanded of anyone who could try to refute this, that any logical system that is complete will inevitably generate a phrase which is unprovable. An example of such a phrase would be, "This statement is false." Because if I'm saying the statement is false and that's true, then the statement is not false. If I'm saying the statement is false and it is false, then I'm stating something which is true. So it's a contradiction. It's an ironical statement which cannot be proven. Now, let's turn away from music as an example here, and let's talk about a worldview which says that the United States was founded on racism, and that someone who would come to a town to defend their father's business from being burned down in a riot is an example of white supremacy. And therefore, it doesn't matter whether Kyle Rittenhouse, according to these people, it doesn't matter whether Kyle Rittenhouse was acting in self-defense or not. He's actually guilty of white supremacy and white privilege and all these other things, and should be the rule of justice according to that logical system is it doesn't matter. He shouldn't even have a trial. He should just be locked up. He should just go to prison for that crime. And so here's the thing. So now we're in a situation where we're understanding, here's how a logical system that says follow the science is using terminology of Russell's "we are under a scientific dictatorship," which is actually not a scientific way of talking and perceiving and organizing and presenting the world. It's actually a logical construct. It's a whole very complex, elaborate construct, which is now finding, as a result of very much so, people who have gotten active, people who have come to their parent-teacher conference meetings, have come to the school board meetings, and they're out there and we're having these conversations. The unproven assumptions the unproven axioms, the contradictory statements are just way out in the open now. And people are seeing that, and they're seeing that it's so arbitrary, it doesn't even make sense. At this point, it's even like, that's the point. That's the point. The point is that it doesn't make sense. They want people to submit to arbitrary rule, to overturn a system of law, as our courts have, and submit to a system of arbitrary rule based upon this constructed universe. So they're not even at this point, they don't even necessarily care that their unproven assumptions don't make sense, logically speaking. That's why the way we're going to defeat this problem is not even by trying to debate the logical assumptions or show the contradictions. We're beyond that point at this point. What we really need to do is, as I was demonstrating with my examples from making sure that geometry is tied to physical proof, as Einstein talked about it, and not being logically consistent within itself, but physical proof, is we need to develop an understanding as a civilization, as a patriotic Americans, as people who love humanity and what we represent in this country and its potential for the entire planet. We need to develop within ourselves the capabilities of saying, this is true, I can prove it, and I'm going to go with this, these sets of policies which are developed from physical proofs. So we can act just deliberately and concertedly and overturn and overrule this coup, which is in a sense really just falling apart anyway. So we can continue riding this ship of our state. And that's what I'm going to go through for the second part of what I'm talking about right now. Okay, so let's carry on here. All right. Here is an example of a physical geometric process. Here's a physical process. It's called, it's been measured and named. It was discovered by Fibonacci. It's a process of ongoing, nonlinear, self-developing change. And it's been measured and it's been drawn geometrically. So the math and the mathematical formulas, the geometric expression of it is actually tracing the physical process. And that is seen here in non-living processes like whole entire galaxies and the spirals that they form, or storms like hurricanes and the spirals that they form. It's seen in living processes. It's, for example, many people are familiar with seashells or flowers. It's also found in the proportions of things, such as the spacing between leaves, or as you see here in my slide, the proportional relationship of finger bones in a X-ray of a hand, the smallest joint's relationship to the next one, which in the relationship to the next one and to the entire hand. And so that self-developing has some interesting qualities to it. If you divide a number in this sequence into the previous number, what you see, and you express that as a decimal that can go on for an infinite number of decimal points, that number never develops into a repeating pattern, like you saw with the square root of 2. Square root of 2 was 1.41, and that 41 repeated, forever. As you get higher and higher and higher in numbers in the Fibonacci sequence, you see that these numbers actually never form a repeating pattern like that. So here is an interesting thing. This sequence is expressed throughout the entire universe as a non-repeating process of developmental change. That's interesting. What does that tell us about the universe we live in? Well, I think, for one example, it tells us that the universe itself is not entropic, that it's not actually winding down. Well, if you can draw a box around something and limit the energy supply in the box, yeah, okay, fine. Things will tend towards an equilibrium in that defined area. But the universe as a whole demonstrates the opposite. Instead of entropy, it actually represents the opposite of that, dynamic change. Bruce will be happy to hear this, but I would call, he's called that dynamic change or dynatropy as a different way to talk about it instead of entropy. This process is also found replicated in human art. And I have some examples here. I have the Mona Lisa from Da Vinci, Michelangelo's creation of Adam from the Sistine Chapel, and the famous wave, tidal wave, or great wave in Japanese art. And all of these and many other paintings and so forth follow this same spiral construction of 1 + 1 is 2, 1 + 2 is 3, 2 + 3 is 5, and so on. And it's interesting because when you, I don't want to get too focused up on this, but again, just to see that when art focuses on and includes and reproduces actual natural or natural laws of development in it, it takes on a quality of proportion, which is easy to find as beautiful. That's the point I'm making on that. So let's examine this dynamic change in a more rigorous manner. Again, the point here of what I'm about to go through is the bigger arc that we're focusing on here is how do we develop and understand laws for society that are not just logical constructs, but are laws which are developed off of physical processes as universally applicable as possible, so that we can develop laws and rules for our society which are in coincidence with natural law. So I'm going to talk about the Russian Einstein. His name was Vladimir Vernadsky. He lived about the same time in what is now Ukraine. And he was a biochemist. So his area of work and expertise was looking at, he first started by looking at crystal structures and their formation. He was the first person to really identify the biosphere as a unique chemical field or envelope of activity, which was distinct from the non-living universe or the abiotic universe. And he then did further work in his later life, identifying a third phase of activity called the Noaa Sphere. And Nous is Greek for mind, the word mind. And he defined the noosphere as the scientific thought of human beings and its fossils. It's as a geological force that shapes the biosphere, that shapes the non-living universe. And what he was examining in these three organized phases is the flow, or what he called the biogenic migration of atoms in the biosphere, the flow of molecules and atoms into and out of these three distinct phases of, or organized phases of atoms. And he was able to, in order to distinguish them, he had to then, of course, qualify that and give ways in which these three phases are distinct from each other. So on the left, I have the abiotic universe. Here we're talking about non-living or inert matter. What we find with the chemical processes of inert matter is that chemical processes are reversible, meaning anything that you can dissolve into a liquid, you can precipitate out of it. That elements degrade down into things and they can be built back up into other elements. Also, that crystal or molecular structures are symmetrical. They're mirror images that you can spin them. Well, no, they're not mirror images. You can spin them and they'll have a line of symmetry somewhere in there. That change, we would measure change in this organized state in terms of geological time. Then we have the biosphere. These are living organisms and their fossils. Things like the atmosphere is actually a fossil of the result of living matter and all the things it's done over geologic time. Also, mineral deposits like iron ore is the result of microscopic animals over geologic time that have slowly deposited, that have eaten and then deposited their waste, which has then been compressed, and we call that a mineral deposit, like banded iron or things like that. And what we find with the biosphere is that chemical processes are irreversible. For example, you cannot uncook an egg. That crystalline and molecular structures that have been created through living activities express non-symmetrical or handedness. In other words, they're reflections of each other. And that life, they're contrary to the primordial soup philosophy, there's no evidence that life has ever been created abiogenically. There's no evidence anywhere in history of a Frankenstein or primordial soup argument ever happening, not in a laboratory, not in nature. And that change is measured in generational timescales rather than geological. When we talk about the Noaa Sphere, we're talking about the realm of human scientific thought and its fossils. We're talking about things like cities, a space station. We're talking about art. We're talking about things that only human beings can create. That scientific thought is completely immaterial. I mean, its ideas are not material, just as life is not. You can't point and say, well, this is where the cow is alive. You can't say, well, this is where the idea exists in your brain, right? It's immaterial. Of course, that's why it's excluded from the logical constructs of Russell's works. But the Noaa Sphere, it depends on the biosphere to exist, but its advancement is actually independent of biology. I mean, Stephen Hawking, for example, his genius was not dependent on being physically fit. Same for, as with biology, there's no example of reproduction of scientific thought that does not come from other scientific thought. We can train animals in laboratories or in farms and other things to closer and closer try to get them to approximate the kind of rational thinking that allows for us, as Kepler did, to counterpose unseen motions with unheard melodies and come up with a system of astronomical forecasting. But no animal does that on their own. No animal has ever shown the ability to domesticate fire and use that. So for that reason, our change, the change in the human species, is not measured by time in the sense of generations or geological scales. It's actually measured instantaneously and back and forth throughout time by the effect of an idea. And now, why did I spend all this time going through that? I know that's a lot. I just presented to you a very, very dense set of three different phases of activity, and I had to qualify how those are different. But this is not a class about Vernadsky. What I was just talking about before is I was talking about how this universe that we inhabit is one of these organizing principles that's behind it has been expressed in what Fibonacci called, right, the Fibonacci sequence. That is something I'm going to talk about next. I want to give you an example in the biosphere of that nonlinear change, that change which is going on. It's not repeating, it's improving, it's organizing itself. And I'm going to give an example of a technology in the biosphere, which is reproductive technology. Okay, a reproductive system. And I have on my screen here the differences, some of the differences in the reproductive technology of entire animal genre. We're looking at fish eggs and then how that's improved under reptiles, and how reptile eggs were improved under birds, and how bird eggs were improved under mammals. So fish. Fish lay their eggs outside of the body. The mother fish attaches them to something. The papa fish comes along and fertilizes them. They're completely dependent on the external environment for hydration, for warmth. The egg shell is permeable, and they lay hundreds of eggs per ovulation because a lot of them get eaten by predators. So they have to do a whole lot of work for something which is very, very exposed. Reptiles, they lay their eggs also outside of the mother's body, but they're fertilized internally, and they're soft shells. So they're partially protected from their environment, but they're still dependent on their environment for warmth and for some moisture to be absorbed from it. So that's why reptiles will be burying their eggs like that. They still have quite a lot of offspring, but it's significantly less than fish. Birds have taken that a step further. While they lay their eggs outside the body and they're fertilized internally, just like reptiles, the shell of the egg is hard, and it creates a barrier where the inside of the egg is basically got everything it needs to allow the ovum to become an offspring, except for heat, right? So the heat is provided by the parent bird, sitting on the eggs. After the bird is born, the parent feeds them, right, through the regurgitation method and some mucus and stuff they do. Also, there's significantly fewer offspring. With mammals, this technology has gotten even more advanced in the sense that the shell that's protecting the offspring from the external environment is now the womb. It's actually inside the body of the mother. And the mother is actively seeking and feeding the offspring by its own nutrition, by a bloodline, right? The umbilical cord. So the heat, the nutrition, the hydration, even the immune system, right, is all provided directly by the parent. And the parent feeds the offspring the same way, right, by breastfeeding, right? And there's significantly fewer of these offspring, right, than there were, say, from birds or reptiles or fish. They're much more advanced because they have these, so you can see there's continuing examples here of upshifts in the technology in something like reproduction. We see I'm not going to go through the other examples, there's plenty of them. The development of a central nervous system, the development of new senses, like sight, pressure, temperature, hearing, things like that. There's all kinds of examples of upshifts in technology that are nonlinear and non-repeating. Now, that's an example of that in the biosphere. I'm going to take it one step further, and now I'm going to talk about the realm of scientific thought. And we would call this, in the LaRouche Political Action Committee, the science of human economy. That human economy, as LaRouche defined it, is a physical science, not a monetary science. It's not a monetary logical system. It's a physical science of how does the human species physically reproduce and improve itself over each generation. And what you can see here on my screen is a historical record of human population growth. And for pretty much all of recorded history, it's under 1 billion people. And then the Industrial Revolution begins, and we have very, very, almost like faster than exponential growth. And we've been able to do this by similar technological upshifts, not necessarily internally to our biology, the way I just showed you with the animal kingdom, but external technologies in the form of upshifts in our modes of production. So here we see a shift and I'm not tying this to the human growth population timeline, but here we see shifts from how we're using fire and what we can do with fire, from a wood burning society to a coal burning society to an oil burning society to a nuclear burning society. And I'll give an example here. I mean, for when you have a wood fire, you have an upper temperature that you can't get to. You can only heat the wood in the fire so hot. You never get a wood fire hot enough to use it for blacksmithing, for example. You really will never get a coal fire hot enough to use it for smelting aluminum and creating an aluminum industry. You need higher forms of temperature control to do those things. Okay, so what we've done here is we're showing how we've been able to concentrate, in the example of fire, we've been able to concentrate fire, increase the amount of what LaRouche called as a principle of his physical economics, to increase the rate of increase in the energy flux density. And what that means is simply is how much heat are you able to put through a given area over time. In other words, you could never boil a pot of water with sunlight. You have to put it over a flame. The flame is much more dense. You're getting a higher density of heat transfer per area with a flame than you ever would from sunlight. And you can boil a pot of water in a few minutes, right? So when we're I'm going to, let's see here, I'm going to stop sharing my screen so that I can look at you again. So, okay, I've covered a lot of things here. And what I want to leave you with before I open it up to the question and answer period is that we're talking about, at the beginning, we were talking about how we want to have a system of rules that are created for our country, which are precise, which are actually scientific rules, that are not arbitrary rules imposed on us by brute force or other methods, to have rules which protect, nurture, foster, and stimulate the creative process in the individual human mind, as by inspiring it to greatness, so that we can do great things like pull people out of poverty through real work, scientifically advanced work in, say, the cutting edges of human knowledge, as in through our space program, or developments of fusion technologies, or upgrading our modes of transportation so that we can get places and do things faster, right? These projects have been known for a long time. When we talk about organizing society this way, there was a gentleman named Alexander Hamilton who was very instrumental in the foundation of our country, and George Washington loved his economic approach and used it in his administration. And Hamilton wrote in a policy paper for George Washington called On the Subject of Manufactures, he wrote, to cherish and stimulate the activity of the human mind by multiplying the objects of enterprise is not among the least considerable of the expedients by which the wealth of a nation may be promoted. In other words, when we nurture genius, we improve our lives economically. Let's start talking about how things like the Bill of Rights, or the principles that are laid out in the Declaration of Independence, the structure of the Constitution, what these sorts of documents are doing is they're organizing a republican system of government, a constitutional republic, which is designed to protect the freedom of the individual, divide power, establish a system for citizen control of the government through public discourse and other methods, right? That the basis and the justification for governing comes from the consent of the governed, not by aristocratic inheritance or other arbitrary methods. To enable a system of government and a society, a system of a cultural system, which cherishes the immortal creative power of the human soul and uses and develops that power to accomplish great things. And that's really what I wanted to get at here when we're, so LaRouche's economics is physical economy. We're looking at a approach to organizing society, which is not arbitrary, but based upon organizing ourselves to mirror and willfully move in line with natural laws of a developing creative universe. And that, of course, also requires developing a culture, art, music, and entertainment, which treat the subject of the human mind and its development as the basis for that. And you see that in a number of works of art, a number of dramas and operas and other things. And that's why our organization is very much promoting what we call the classical mode of art. So that kind of hopefully ties everything that I did last week back into what I'm doing this week. And I would like to end my remarks at this point so that we can have a conversation about that.